As I mentioned in the previous class, probability and set theory are very much related. In fact, to understand the probability theory very well, you need a good understanding of the set theory. And that is why I'm taking my time to make sure that you understand the set theory before I actually go into the basics of probability theory, where we are going to start with conditional probability. I'll recommend you subscribe to my channel by clicking the subscribe button below this video. In that way, you get updated when a new lesson is made. So let's go ahead to discuss the set theory. This is the last class in the set theory we are going to discuss. We are going to talk about sample space, union, intersection, complement, disjoint, and empty set. Now let's talk about the sample space first. Probability has to do with carrying out experiments and then trying to find out the possibility of something happening in a larger space. So let's say in a population you want to find out how many persons earn above XYZ dollars. You have to collect a few of the people, let's say 100 or 1,000 people, and check how much they earn. So if 50% of this number you collected earn above XYZ, then you can conclude that 50% of the population of the country earn above XYZ. So basically, we are saying that a subset of the population could represent the population at large. So this subset we are going to be using is called the sample space, and we only have to work with the sample space almost every time because there's no possibility, it's difficult to work with the whole population or going to take measurement from everything in the population. So now we are going to represent the sample space, and then we are going to try to understand what union is, intersection, complement, disjoint, and an empty set. So let's say the sample space is a set of items. So now I'm going to take a pen. Let's see. I'll use this. So let's represent the sample space with this symbol. I think this should be rho. So it's going to be so each time we are writing about trying to create sets, it's better we use curly braces. So in this way. Okay, so we have C, C, C. So we have separated by a comma C, C, S. We have C, S, S. We have S, S, S. Then we have C, S, C. Then we have S, S, C. Then we have SCC and SCS. So it seems my writing is not the best, but let me see if I can make this one a little better. So this one. So what has to be there is CSC. So we have CSC. So I recommend you also follow along in your system so that we see how we can do this together. Alright? So now this is our sample space. We've collected a few samples from the population. How many items are there? We have 1, 2, 3, 4, 5, 6, 7, 8. So 8 items that we have. So now let's say that A is equal to let's say SSS, SCS, and SCC, and SSC. And let's say that B is equal to CCC, CCS, CSC, and CSX. Okay. So the question now is, we want to now talk about union. So union of A and B, A union B, what is it going to be? So union of two things or two sets is combination of everything in that set, and then you remove the duplicate. So in this case we have a SSS, we have SSS, we have SCS, we have SCC, we have SSC, we have CCC, we have CCS, we have CSC, and we have CSS. So there is a union of A and B. So A means A has to do with have SSS, SCS, SCC, and SSC. What this means that we have about how many events? 1, 2, 3, 4. 4 events in each. So the union of the two is the combination of all these events and making up 8 different events. Now, when we have intersection A intersection B, so my writing is not very good. So it's going to give us items that are in A and also in B at the same time. So in this case, there are some things that this is in A that is in B as well. SSS is not there, SCS, SCC, SSC. So basically, there is nothing there. Alright, so we have an empty set. So the next thing we want to talk about is complement. So a complement refers to items that are in the universal set or in the sample space, but they are not available in A. So I could simply say that a complement is equal to CCC, CCS, and we have SCC, and we have SSC. So basically this is the same as B. A complement is equal to B, right? So let's say B complement. I'm going to allow you to write it yourself. So list out the B complement. Now let's talk about this joint. So this joint means that two sets has no complement, has no intersection. So we can say that, so give it a second. So we have set A and B are this joint. So two sets are disjoint when A intersection B is the empty set. So at this point, when we have something like this, A intersection B is equal to the empty set, we say that those two sets are disjoint. So basically we've covered the main things. So how does now all of this relate to probability? So this is now how we are going to continue with the probability theory in the next class. So these are the basics of the set theory. I want you to understand it, and we now continue in the next class with conditional probability.